the cells, any object or any system which supplies the current or which maintains the current or which maintains the potential difference in a circuit, it is called as a, we are going to call it as an electrochemical cell, because it is going to store the energy in the chemical form, and when it is connected to a circuit, it is going to supply that energy in the form of electricity or in the form of electric current. If we have a group of cells, then we call it as a battery. A battery is a group of cells. It can also be a single cell or it can be a group of cells. Next thing is EMF. EMF stands for electromotive force. In reality, there is no such force that exists in the third thing, that is the internal resistance. It is inside the cell. We know we have an electrolyte. If we have an electrolyte, it is a liquid, it is a solution which contains the positive ions and negative ions, and if we make those ions to move in a particular direction, let us say positive ions are going towards one side, at the same time the negative ions will be moving to the other side. When that movement of charges takes place, there will be some opposition to that flow of current. What is flow of current? The movement of charges. There will be some resistance offered by the electrolyte. That resistance of the cell which is present inside the cell due to the electrolyte, it is called as internal resistance. What is the cell consist of? So it will be usually a container, and that container has some kind of an electrolyte. It is mostly for a standard cell, we use H2SO4, that is sulfuric acid, as our electrolyte. Now inside that electrolyte, we will be having two plates. Of course, one of them will be the positive plate and one of them will be a negative plate. Let us say this is the positive plate and this is the negative plate. So the chemical properties of the materials used inside the plates, one plate is going to attract only the positive ions towards itself, and that plate becomes positively charged. The other plate, it is going to attract only the negative ions towards itself. Hence, this plate becomes negatively charged. Now, if we have charges on the plates, we know that if there is a charge present somewhere, it is going to create a potential around itself. Let us take 2 points. One is on this plate, that is a positive plate. Let's call that as point A. And on the negative plate, let us call there is a point B. Now, if I want the charges to move in a particular direction, then there should be a small potential difference. So there will be one positive potential. I will call that positive potential as V plus. Similarly, if I look at this plate which has got negative charges accumulated onto it or the negative ions onto it, what happens there? It is going to develop a negative potential with respect to the electrolyte which is surrounding the negative plate, and that potential I am going to call it as V minus. This negative represents that the plate is negative, and this negative sign again which is on the outside, it is going to represent that this potential is negative with respect to the electrolyte which is surrounding that plate. We know that this potential, it has to be greater than 0, and this potential, it has to be less than 0. So with that as the basis, these 2 points will have some potential difference between them, and that potential difference we are going to call as EMF. Now this cell, if I want to represent it in my circuit, then I'm going to put a symbol which looks like this. Now I'm going to introduce a new term here. It is epsilon. This epsilon, it is the potential difference between the points A and the point B. How it is going to be? It is the potential difference between the point A and point B. Now, what that potential difference is going to do inside the electrolyte? We know that the current flows from the higher potential to the lower potential. Positive charges, because they are getting attracted, they will be moving from point B towards point A, and the negative ions, they will be attracted by the point B, so they will be moving towards point B. So the total potential difference between these 2 points will be the difference between the two. So this is going to be V plus minus of minus V minus. Now, if I simplify this, it will be V plus of, because there is a minus sign twice, it will be minus into minus plus, it will be V minus. So this is the kind of potential difference that develops between these two plates. Now, I have got the positive terminal open. I have the negative terminal open. I have not connected anything to those terminals. The same cell, what I have here is, there is a positive plate, there is a negative plate. Here is my point A, here is my point B, that is point P, and this is point N, or I can take positive sign and a negative sign, and it is filled with the electrolyte. Now, this is the situation when there is nothing connected between the two terminals, that is P side and the N side. Now, if I connect something to these two terminals, let us take the simplest component, that is our resistor. So let us call this side as point C. Let's call this as point D. Now, if this resistor is connected across the terminals of the cell, then first thing I will draw the circuit diagram how it looks like. So I have a cell, I have a resistor, and this is how they are connected. This is my point P, this is my point N, this is my point C, this is my point D, there is a resistor R. Now, if this is the setup, then there will be a current starting to flow from the positive terminal to the negative terminal through the resistance. So there will be a current, it will start from the positive terminal, it will go to point C, I'll call that as current I. That current will flow across the resistor and it will come out from point D, and again I'm going to get the same current, and that current will enter back into the cell. So the current will flow in the circuit only when the path is complete. Here we have the potential difference. We will get the voltage because it has got an EMF. But if we want the current to flow, that means there should be an external circuit between the terminals of our cell. Same thing is represented here. I can put a plus and minus here. What is happening here is there is a current I flowing here, and the same current is coming out from the other side. Now, in this case, if I want to calculate the potential difference across this battery, then it is going to be, let's call that as V. Where is V? V is the potential difference between the points P and N. Let us consider only the flow only across this much of region. How the charges are moving only inside this region. Now we have a potential between A and the surrounding electrolyte, and for that I had used this V plus. Similarly, I had V minus. So there was a potential V plus between point A, which is on the plate, and to the surrounding electrolyte, and that was my V plus. Similarly, VB will have a potential difference of V minus, and these two together I called it as the EMF. Now, this is point and the nearby electrolyte, the point and the nearby electrolyte. But What about the electrolyte which is between those 2 points? So if I have this much, let us say it is with point A and this much is with point B, there is still so much of path or so much of distance that is present between the 2 points, that is A and B. There will be a small resistance developed between the 2 points A and B. And when that happens, and that happens only when the current is flowing. If I have this diagram, if I want to look into the resistance which is present here, there will be no resistance because there is nothing is flowing. The resistance will be present only when the current flows. So in this circuit or in this diagram, I don't have the current flowing because that circuit is not complete. But whereas in this, I have that external path and that is going to complete the path, and when the current flows on the outside, at the same time, the current flows on the inside. And that electrolyte through which the current is flowing, it is going to offer some small resistance. And that resistance, we are going to call it as this internal resistance. If I apply Ohm's law across this region inside the electrolyte, it will be V equals I into that small letter r. Now if I want to complete the same equation, it will be V equal to V plus of minus I into r plus of V minus, and from here I already have that epsilon equal to V plus of V minus, and that is going to give me epsilon minus I into r, and that is my terminal potential. This equation is valid only when there is a current flowing in the external circuit, and that external circuit will have V equals I into R. What is this V? This V represents the terminal potential difference. Where is it present? It is present between this point and this point. That is point P and point N. That is where we are going to see this potential V, which is epsilon minus I into R. Then coming to here, when no current is flowing, there will be only V plus, there will be only V minus, because there is no term of I. If I want to calculate the terminal potential difference here, it will be V equal to epsilon directly. But when the current flows, the ions will move. There will be some opposition to the movement of those ions, and those ions are going to offer that small resistance, and that is going to reduce the total value of the terminal potential, and it will be slightly less than this EMF, and that value is given by I into small letter r. I have a cell. What is a cell? It is an electrochemical composition which supplies the current. Then it is going to develop an EMF across its terminal. What is an EMF? It is the potential difference that exists across the terminals of a cell when no current is drawn from that cell. Then what is internal resistance? It is the resistance offered by the electrolyte present inside the cells. Ideal case, this internal resistance should be 0. So whatever the potential difference we are measuring, it should be equal to this EMF. But in real world, all the cells, they are not perfect. There will be some small value of internal resistance that exists with each and every cell. I have this V epsilon minus I into R. But this V is also the potential difference that exists across this resistance R. So can I equate those two? This equation and this equation both represents for V. So I can write as IR equals epsilon minus I into small letter r. Now I can find the value of current from this equation, or I can also find the value of small r from this equation. Rearrange this equation. I will take this to the left hand side. It will be IR plus I into small letter r. That is going to give us epsilon. I can take I common here. It will become r plus r, and this will be equal to epsilon. If I want the value of current, it will be epsilon divided by R plus R. Ideal case would be that external resistor should become a 0. If that happens, then we will call this setup as a short circuit. In that case, I will be equal to epsilon divided by only small letter r, and this is the equation for I max. So what is I max? It is the maximum current that can be supplied from this cell. This is the case when R became equal to 0. There is another possibility in which R becomes infinity. That is, it is called as open circuit. That means there is no connection between the positive terminal and the negative terminal. In that case, R becomes infinity. If I want to calculate that current, it will be equal to epsilon divided by R plus R. Now, if I substitute infinity in the denominator, what is going to happen? It is going to become 0. If there is an open circuit, no current flows, and that situation is similar to this one where nothing is connected between the positive terminal and the negative terminal. Similarly, if you look here, if I want to calculate V here, now what is V? V is equal to epsilon R divided by R plus R. Now, where did I get this equation? It is from Ohm's law. V is equal to I into R. That is my Ohm's law for the outer part of the circuit. Now, what I have for I is epsilon. I can write V as I can be replaced by epsilon divided by R plus R into R. So that is my relationship for the potential V, and that relationship I have used here. Now what happens here is, if this R becomes infinity, there is an infinity in the numerator. Similarly, there will be an infinity in the denominator. So infinity by infinity, it is an undeterminate form in mathematics. So we cannot solve that circuit directly. So what we do here is we are going to slightly modify this equation using the mathematics. So this is going to become V is equal to dividing numerator and denominator both by R. So it is going to become epsilon R divided by R whole divided by R plus R whole divided by R. Now what happens here is, there is a R here. So what I get here is, it is going to be epsilon, because this R and R will be getting cancelled, divided by, in this case I will get two terms. In the first term, this R and R will be getting cancelled. I will get a 1. Then there is a R divided by capital R. Now in this equation, if I replace this R by infinity, that means this term becomes 0 and V will be equal to epsilon. That is the case when there is an open circuit. That is exactly how we define the word EMF. EMF is the potential difference that exists between the terminals of a cell when there is no external circuit connected, or the external circuit is broken, or the external circuit is not letting any current to flow, in which case the circuit will be called as open circuit.